Hi everyone. So I'm going to do this this problem that you guys are having a little bit of difficulty with. It's going to be problem 3 of the kinematics acceleration problems 5, I think. So I'm going to just write that here. Kinematics problems 5. This is the first of the 2 complicated ones. So I'm going to do this one and I'm going to do the other one, and hopefully you guys can follow. So I'm just going to read the question. A plane flies 1,200 meters over you and drops a person in a parachute. If the person's acceleration is -1 meters per second squared and her velocity is maxed out at 8 meters per second due to the resistance of the parachute, how long does it take for the person to reach the ground? Assume that she opens her parachute as soon as she jumps out. So we're not dealing with anything that has to do with free fall, and so we don't need to use -9.8 meters per second squared at all in this problem. All right, so let's start. I have an initial position of 1,200 meters. All right, I'm just writing down what's given to me here, and I'll determine what I need to do with them afterwards. I have an acceleration of -1 meters per second squared, and I have a velocity max, and this doesn't mean anything yet, but we're just going to get to it later, of -8 meters per second. And I put the minus there because we're falling off a plane, so we're going towards the origin, and therefore the velocity has to be negative. All right, so if we look at what we have here, we have a position, we have an acceleration, and we have a velocity, all right? And that's really hard to work with because there are 3 different degrees. Do we draw a PT graph, an AT graph, or a VT graph? The only one that has all 3 in them is the VT graph, and I'll show you why in a sec. So this is not going to work this way, but if I draw the graph like this, and I have velocity here and time here, we know that when you jump off the plane, your velocity is 0, and then you start accelerating, and then you reach a maximum speed of about 8 meters per second, or -8 meters per second. All right? And then you plateau until you reach the ground. So then after that, your velocity is constant at -8 meters per second. So no more acceleration. The reason I chose to do the VT graph is because I can use the slope here to figure out acceleration, and I can use the area under the curve to figure out position. So the VT graph actually has information about all 3 parameters that we're interested in. So I said that the initial drop, your acceleration is -1 meters per second squared. So that's the slope of that area right there. All right, and here, because your velocity is constant, the acceleration is 0 meters per second squared. All right, okay. We know that the area under the curve, this whole area here, is equal to this many meters, right? Because after that, you land on the ground, and you don't know what happens there. So if you want to find the time at which, so I'm going to call this T1, the time at which you land on the ground is when the area of the curve is equal to 1,200. All right, so that means you have to somehow find the area of the curve in section A and the area of the curve in section B. All right? All right. So the first thing we need to do is do the area of A. So I'm going to do step 1, find the area of section A. In order to do that, we need this time point here. I'm going to call this point T prime. All right. So what T prime does it take for? Is that what T prime is that? Here we have velocity, a maximum velocity, and we have a slope which is represented by the acceleration. So we know that acceleration is equal to delta V over delta T, right? And we know that acceleration is equal to -1 meters per second squared, and that's equal to the change in velocity, which the initial one was 0 and the final was -8. So final minus initial divided by the amount of time that that took. And we don't really know what that is, but that's what we're looking for. So if we figure out the algebra here, we know that t is equal to 8 seconds. Perfect. So that means this t here is equal to 8 seconds, and we can figure out the area of A. So A is equal to 8 meters per second, or sorry, rather negative 8 meters per second, times 8 seconds divided by 2 because it's a triangle. So that's just a formula of a triangle. That's equal to 32 meters. All right? So area A is 32 meters. That means, so now we go into step 2, area B is equal to 1200 minus 32, which is equal to 1168 meters. All right, so this whole area is 1168. Now we know what the constant, that it's a constant velocity, and we know what the area underneath the curve is, right? So this part is easy. We know that velocity is equal to the change in position over the change in time, right? And we have velocity, which is negative 8 meters per second, and that's equal to the change in distance, which is 1,168 meters, divided by the time. I'm just going to put a negative here because I know that my time needs to be positive, divided by the time. So when we work that out, t is equal to 146 seconds. All right? And so now if we want to find out the total time, we have to add the times for this period and for this period. All right? So step 3 would just be to add up those two. 146 seconds plus 8 seconds is equal to 154 seconds. And that's the final answer. I want to make sure that certain things about the distance are clear, because I wrote here minus 8 meters per second, and then I gave an answer that's a positive number, and here I did the same thing, and I just told you it's because I want positive numbers. But in fact, what's happening is you're starting at 1,200 meters in the sky, and your position is changing in the negative direction as you're falling down. You don't need to concern yourself with that. All you need to know is that you have to somehow get from plus 1,200 all the way down to 0. And in order to do that, you need to go down an altitude. So this is going to be minus 32 meters. So your displacement at the beginning went from 1,200 meters to down to 1,168 meters, and then from there 1,168 meters down to 0 meters, and that's why it's negative. All right? I hope that's clear, because I'm about to start the second part of the problem, and that one's a little bit more complicated. All right. So here it is, problem number 4. This one's going to be a bit longer because there's a few things that we need to take note of. So I'm just going to read the question. A plane flies at 1,200 meters over you and drops a person in a parachute. If her velocity cannot be higher than 8 meters per second due to the resistance of the parachute, A, how long does it take for the person to reach the ground? Assume that she opens her parachute after falling 200 meters. And B, what is the deceleration caused by the parachute if it takes her 1 second to reach her max speed? All right, so again, we have an initial position, which is 1,200 meters. We have this velocity, which is equal to negative 8 meters per second. And this time, we're in free fall, so acceleration is going to be negative 9.8 meters per second squared. All right, so again, we have a position, we have a velocity, we have an acceleration, and therefore, what we have to use is a VT graph. So I'm going to draw it again, very similar to the last one. But this one is going to look a tiny bit different. And this is the kind of tricky part when it comes to solving these problems. And I admit that this problem is actually kind of hard. I definitely won't be asking you a question like this on a test, but I really want you to understand exactly what's happening. Probably right there I lost half of you from listening to this, but anyways, for those of you who are sticking around, let's do this. Essentially, you're jumping out of the plane, and then you're free falling. All right, so you free fall, you free fall, you free fall. The slope of this free fall because we have a vt graph, the slope is acceleration, is negative 9.8 meters per second squared. All right? And then however long it takes, you open your parachute. Let's see, at this point, you open your parachute. And then all of a sudden, whatever your velocity is there, it slows down. I don't know if you've ever seen a video of someone jumping out of a plane and opening their parachute. So they fall fast, and they open their parachute, and it looks like they get pushed upwards. And that's because they slow down their speed so fast. So essentially what's happening is it's going to slow down, and then it's going to float down at 8 meters per second. So this here is negative 8 meters per second. All right? However, we know that you opened your parachute after falling 200 meters. All right, so that means this area here is equal to 200 meters. All right, so we can use that information to find t, and we know that this area here, because that's the remainder of the flight path, of the fall path, you know that that's 1,000 meters. You already have those areas. And this is another interesting t. All right, so you have to find the first t and then the second t and add them together to figure out how long it takes for this person to reach the ground. All right, let's start. The first thing we need to do is figure out when this t falls. All right, in order to do that, we need to understand that position as a function of time is equal to, when we're in free fall, 1/2 of negative 9.8 meters per second squared times t squared. This is just how we've been doing parabola problems up until now. So hopefully it's not too new for you guys. And we want to find the time at which position is equal to 200. So if we do this, we want to know at what time position is 200. All right, so 1/2 times negative 9.8 meters per second squared times time squared. All right, so I'm going to solve for t, and I'm hoping you guys can do that. So it's negative 200 times 2 divided by negative 9.8, all that square root. That's equal to 6.4 seconds. All right, so that means this time here is 6.4 seconds. Perfect. Now 2, we need to figure out the time at which this happens. All right? So the way we do that is same as the last problem. So we have velocity is equal to the displacement, the change in displacement, over the change in time. All right? So now delta d is equal to, well, let me just rewrite this. So we know that it's minus 8 meters per second is equal to the change in the displacement, which is negative 1,000 meters, divided by a time. All right, and therefore if we solve for that, time is equal to 125 seconds. All right, so the answer to A would be 125 seconds plus 6.4 seconds. And if we're going to be really, really picky here, and then we read ahead, it says that the parachute takes 1 second to reach its maximum speed, to reach that maximum speed, so we can add 1 second here. Right, so the part where you pull on the parachute string, and by the time you slow down to those 8 meters per second, it took 1 second, so we add all those times up, and we got 132.4 seconds total. That's A. All right, now B. B is asking you what the deceleration is. So you started off here, you're going really, really fast, and then in the period of 1 second, you dropped your velocity to minus 8 meters per second. So we have to figure out how fast you're going at this moment. And that's easy, because if we look at the graph, up until here is a linear curve, right? So you guys know this as y equals mx plus b, or I'm going to call it v is equal to at plus vo. Right? What's the original velocity? That's 0 meters per second. Acceleration is negative 9, negative 9.8. Oh, I have no room here. So I'm just going to erase this. So it's negative 9.8 meters per second squared times time, and we know this time is 6.4 seconds, plus the original velocity, which is 0 meters per second. Alright, and we can solve for what that v is at this point. And if we do, the answer to that is minus 9.8 times 6.4, and v is equal to negative 62.72 meters per second. So now we want to find that acceleration. And we know that acceleration is a change in velocity over the change in time. And the change in velocity, well, the final velocity is minus 8 meters per second, minus the initial velocity, which is minus 62.72, divided by, and I said in the question, it takes 1 second to do that. That's not a 1. It takes 1 second to do that. So we can figure out what the acceleration is. And acceleration is minus 8 minus negative 62.72 divided by 1. So 54.72 meters per second squared. And that is your answer. That's the acceleration or the deceleration that you underwent when you opened your parachute. I'm just going to leave that up for a couple seconds so you can take a look at it. I'm going to post all of these solutions online as well. It might not be this exact copy of it, but the answers will be the same. I hope that that worked for you. I hope you guys were able to follow that. Again, I won't ask you such a complicated question on the test without giving you this formula. So what really made this problem difficult was knowing this formula here. Once you're given these formulas, which we're gonna do in the next section, in the 1D and 2D ballistics, these formulas will be given to you, and so therefore you don't have to kind of make it up on your own like that. All right? All right, I hope that helps. Thank you.